So what is the setup? How should I start? What will be the first step? Any idea? Any idea?
Do we use a branch make process?
Not yet. I think next step.
See how the process, right? We're going like y is equal to y times u1 over u1 times u2.
Yeah. So the space that I have, the subspace that I have is spanned by u1, u2, right? I wanna project y onto the space that I have that is spanned by u1, u2. And what is the formula? I'll give you the formula. This y hat, the projection onto the space that I have, spanned by these vectors. Then these are the formula. I'll give you for the exam. For the practice, good to test yourself. You know this, but I'll give you this theory for the exam. So this is the formula. And then dot product, right? This. We did it in class. Actually, you guys work this problem on the board. And then the answer you get is this. Now I may ask, what is the error of y hat? Then how should you compute error of y hat? Is that it?
Square root everything in the square.
Yes. So it's not just y minus y hat. You have to find the length of this. Right? Length of this would be the error. Okay. Make sense? At like measuring the error, to measure the error, you have to know how to compute the length. That's why I just want to go over the definition of length. Where is it? It is. Okay. Just simply squaring each entry, sum them up, and put square on top of this. Okay. Vector suite. Okay, this is distance. When you're learning this distance, find the distance between two vectors. 2 weeks ago, 3 weeks ago, when you're learning 6.1 for the first time, you had no idea why this is important. But now you know why this is important. Why do you learn this? Because you want to find the length or distance between y minus y hat. This is purpose. That's why we learn this concept. Okay? As machine learning or any applied science, true minus estimation or approximation. This is it. And you want to find how big the error is, and you try to get the length or distance, right? The absolute value of that error. This one is so simple. I mean, you have to know. You have to know this. this concept. Otherwise, you cannot get the error. You cannot compute the error if you don't understand it. Orthogonal vectors. Nothing. All I ask is angle related. You need to start. Orthogonal set is. How do I show this our orthogonal set?
You're gonna show that each one is orthogonal to each other. So U1 to U2, U1 to U3, U2 to
Oh, thank you, David. So you have to test each pair, every possible pairs. Okay? You multiply. You compute the dot product of each pair and see if all of them are zero. If one of them is not zero, then it's not orthogonal set. Okay? Why do you learn this? Why do you learn orthogonal sets? So basically, 6.1, 6.2, 6.3 is like helping you understand the foundation of Gram-Schmidt or projection. So that's why we learn orthogonal sets at the beginning. But why this is important in terms of Gram-Schmidt or projection? Computer can do it, ChatGPT can do it, but why is it important? Why human beings? You guys are important because you have to know how to interpret this. Why? Why this is important? Why finding out orthogonal set is important? Hint is orthonormal matrix. Why do you bother with using Gram-Schmidt? You'll be shocked. It's okay. I'll go over it. Yeah, I'll talk about it when we go over it the next chapter. But anyway, so good. Once you have orthonormal set, right? Like this. The last chapter we learned, we decomposed APDP inverse, right? For the last example. And then for the last chapter we learned, we can transform word. We can replace this with what? Yes. Why do we do that? Yes. Normalizing P, meaning find the length of each vector and then dividing each vector by its own length, normalizing it, is a lot cheaper than finding the inverse. That's why. And once you find the orthonormal vectors, orthonormal basis, which is component of P. So once you find the orthonormal basis, you can just simply find the inverse, which is just transpose of this. And that's why. To reduce the computational cost. That's why we learn orthonormal sets. Okay, anyway, so how do you find out the, how do you find out? You just compare each pairs. Compute dot product of each pair and see if those results are all zero. And true, false. Like this. If you have orthogonal set, then this should be independent because they're not scale of each other. The vectors here are not scale of each other because they're orthogonal, and it should be a basis for subspace. I'll give you this formula but when you're practicing it, when you're studying by yourself, you should know this. Although I'll give you the formula. Okay, try this. This. So you have a space spanned by, you have subspace spanned by U1, U2, U3, and then you want to see if Y is a part of this space. How can we know this?
Could do an offensive.
Yes. Okay, so this is what we want to see. What do you want to compute? And if you get unique, if you get consistent solution, then what is conclusion? Y that Y is in the subspace spanned by U1, U2, U2. However, if you cannot find the solution, then what can you do?
You have to estimate it.
Yes, estimate. Like yes. Then that case, in that way, you have to find Y hat. So instead of using the row reducer, using augment matrix, we can also use this formula. It's still valid. So this formula is same as this formula is same as finding U hat. Don't you think so? You're saying finding U hat and finding U is same. Why? Here you're assuming that Y is in the subspace that I have. But if the Y that I want to express using the basis that I have, if the Y is not in the space, then you have to estimate. That's why this theory is different from the next theory here. It makes sense? So here, this right hand side is all same, but Y and Y hat are this left hand side is different. Does it make sense? Because you're assuming that Y is not in the subspace. In this case, you're thinking of the case that Y is not in the subspace. If Y is in the subspace, then this is same as Y. Okay. If I explain this picture, if Y is in the subspace, then you can accurately find each scalar vectors, like the scales of each vectors. Okay. But if Y is out of this subspace that I have, then you have to estimate. In that case, you write Y hat instead of Y.
So
Yes.
because W is a two-dimensional plane and Y is in the third dimension, you're saying that Y hat is obviously just an estimate of where Y would be.
Yes, I mean the estimate. The estimate means I want to express Y in the space that I have. This is the best I can do. Y had this. Let's try this. You have 2D space. You got one vector for your basis, for your subspace, and Y is something that I want to estimate or approximate. I want to find Y hat. using this formula. What is y hat?
Page 4.
Okay. Remember you guys draw this on the board? So graphically speaking, y. You project y. You get y hat. But what is the distance? This is the distance. Right? Y minus y hat. And that will be the error. This part. So y hat, y minus y hat will be the distance, the error. If I ask you, hey, also find the y hat, also find the error of y hat, then you should find y minus y hat, compute that, and then the length is minus 1 square plus 2 square, and that will be the error of y. Okay. So this is important, like understanding this basic, this concept on the 2D dimensional is really important because the dimension is getting higher and higher. You have to understand this concept. Any question? No? I mean, the calculation is just like if you, please try by yourself and try by yourself if you can draw this and understand what this line is. I mean, y. If you have y, can you draw y hat? Okay, once you draw y hat, what is the error? This much. And the error is expressed by the length of y minus y hat. Okay, now orthogonal set. Instead of orthogonal set. What is the difference between orthogonal set and orthonormal set?
The orthonormal is just the orthogonal basis normalized.
Normalized. Yes. So, to show if this set is orthonormal, what do we have to show? Two things we have to show. First, orthogonal. Second, normal, right? How do you show orthogonal? How do you show? And dot product. And see the results are all 0. Normal, just simply get the length of each vector, see if all of them are equal to 1. Okay? This is so important. This is so important. Once you have a orthonormal basis, orthonormal columns, then if you transpose that, so this, if I construct a matrix, literally copy and paste this, copy paste orthonormal vectors, and then construct a new matrix. Okay, now literally copy paste each vector and call this U. Okay, U. What is the inverse of this? U. Yes. So let's say I give you some really crazy gigantic matrix that is orthogonal vectors. Let's say if I ask you to find U inverse, you just simply transpose. Okay, don't panic. And okay, so this. And why do you care about this? Because of this decomposition. Because I don't want to compute inverse. That's right. Okay. These are so simple. 6.3. We did it. One minute. Projection. Okay, this. Okay. Okay. Find the closest point to y in the space that I have would be what? Okay, you got a space. You have, so you're playing this game in three-dimensional space R2. You have two independent vectors, and that'll make a subspace. And you have y, and I want to project y onto the space that I have. And then the y hat will be the closest point to y. So instead of asking me directly, hey, compute the projection of y onto the space that I have w, instead of asking this, instead of just explicitly asking you to find this, I may say, hey, find the closest point, and this is same. This is same as this. The formula of y hat is literally this. Okay? The meaning of the projection is this also. Okay? Okay? Okay. Graham Schmidt. Okay, let's try this. Try this. Do you guys want to work on this board? Or do you want to work on your paper? Okay, okay. Whatever you prefer. Graham Schmidt. Solve this. Tell me the answer. You need formula? Yeah, I decided. For exam, so for the final exam, for exam 1 and 2, I'll just copy paste true false to reduce the pressure that you feel to study to study the previous one. Is that okay?
Just the true false?
Yeah, just true false. Just true false. So no other the free answer question from the previous one.
Is it like the last test where it's like minus a point if we get the true false wrong?
Yes. Okay. But it's okay, but like to study the questions, and if you master those, you'll get good grade. Okay. Or do you want other rate?
That's fine.
So they would be the same ones from the last test?
Yes. I'll select. I cannot copy all of them. But, I'll select a few from first exam, a few from second exam, and also I'll make new true false questions from new contents.
Can you tell us which ones you're picking?
Yeah.
Can you tell us which ones you're picking?
Are you gonna you're gonna post the review
This one?
week?
Yeah. Okay. Valerie, thank you always for reminding me. Okay.
Can you tell us which true false ones you're not gonna pick?
Yeah.
No, you said 1 and 2.
Yeah.
Which one's that?
Which one do you prefer? I'm being honest. Which one do you prefer?
Just repeat test one.
Huh?
Just do test one over again, exactly the same.
Didn't we do it?
Okay, so maybe not. I'll just do this. For chapter 6 and 7, we don't have that much true false state, like the properties or theories. So for studying new contents regarding true false, it's not that hard, I guess.
Can you post in a single PDF all of them falses? The ones you're gonna.
Okay. Yes, I'll do it, man. I'll do it. So which one is true false for first exam and second exam, and also true false for me? Okay. Yes, ma'am. I'll do it.
That's okay.
Okay. But you have to promise you study hard. Because the time that I spent for you guys has to be worth it. What else? Any suggestion? So the exam, for the last exam, one question from Graham Schmidt, one question from 6.4, one question from 6.5. So one question from each chapter, excluding 6.1, 6.2, 6.3, because those are all simple concepts. So 6.5, yeah, let's go. Also, I'll try to make it not that hard.
Did you say how many questions the test has?
Not decided yet. I'll make today or tomorrow. How many you want?
2.
Okay. If you want, okay. True false has to be between 10 and 20, because it has to be cumulative. But the new content, how many questions do you want? I'm willing to cooperate with you, because it's last
Nothing
exam.
from 6.5.
6.5?
Nothing from 6.5.
So I guess what you want is 4, or between between 1 to 4.
Wait.
One is if you mess up, then you're done.
Yeah. Oh, wait, so
Would it be a more spectacularly hard one question?
If it's one question, then it has to be long.
Remember it well.
One question, find the inverse, that's it.
Find the inverse of gigantic matrix. So if you want to,
Diagonal basis of a 30 by 30.
pardon me?
orthogonal basis of a 30 by 30?
No.
Wow.
All of you will fail.
I think we could do one by each chapter. So.
Yeah, I think that'd be good. Honestly, because so that way I can test you if you understand concepts overall, not testing only one concept.
So, one question for each chapter. Is that still excluding 6.1, 6.2, 6.3?
Yeah. Because those concepts are already included from already included here, Gram-Schmidt. You have to know projection, you have to know length, orthonormality, you have to know all of this. Okay, so how do you do this? You just compute this, you get this. But if I ask you what is the meaning of this, what would you say? Why Gram-Schmidt is useful? Why is it useful? Yes, orthogonal basis, and then normalize it. Then you have orthogonal basis. And it is easy to find transpose. Inverse, which is transpose. Okay. So try this by yourself if you didn't get the answer. Okay, this one too. I'll make it simpler for the last exam, but try this. I mean, computing each step is quite hard, but just tell me how to solve this. Big picture. How do you find the orthogonal basis?
Well, V1 is equal to X1.
You fix first vector, and then?
And then V2 is equal to X2 minus projection of X2 onto X1.
Okay, great. And then?
And then V3 is X3 minus projection of X3 onto V2 minus projection of X3 onto V1.
Okay, thank you. So that is perfect answer. So, like if you read the book and then all the steps are written, so try by yourself if you get the same answer. Okay? I'll give you this one definitely. You don't have to memorize it. But understanding that concept, just like what Chris said, that is really important. Orthogonal basis. Okay, you have orthogonal basis. I want to normalize. How do you do? Divide each vector by its okay. QR. Why is it handy? Why is it useful? Once you know Q and R, why is it handy? Why is it useful? Thanks. The fundamental problem of linear algebra is you have input vector x and you want to transform this A. Then you want to find some solution regarding some the determined output, let's say B. Okay. So if you know this A and B, I want to find x. And I want to find the solution. This is what we have done, chapter 1. Right? I'll go into matrix, find the solution. But instead of A, if you have Q R, why is it handy? Why is it useful? What?
It reduces computational costs.
Yes. But how? Okay.
Because
How?
R is invertible now, and you can multiply by the inverse of R, and then you can use Q transpose to create the identity matrix.
Okay, so we don't even need to compute the Q inverse, right? Because Q inverse is Q transpose, right? So you want to multiply both sides from the left, Q T, and then this goes away, right? This goes away because it's I. Then once we have upper triangle matrix multiplied by X, you can find the solution from the bottom, right? So, meaning, where is it? Doesn't have it. Do I have it? I think we have something. We have some example. So let's say you have R and you have X, and then you have QB. Let's say QB is it's some number. Let's say 1, 2, 3. Can you find a solution right away? Is it hard to find solution? Yeah, you can find the solution right there. X3 is, you can find immediately. Right? X3 times this number is equal to 3. Therefore, you can find the X3 easily. Once you find X3, you can find X2 using the value of X3. Right? Once you find X2 and X3, you can find X1 using this. Multiplying this by X2 and X3 and move this to the right hand side. Okay. And practice by yourself how to find the Q and R. Okay. This is from these vectors are from the previous example. I'll skip this. It's quite long. Let's try by yourself. Okay. Okay. Lisker. Okay. I give you A and B. I want you to find X hat. And then what should we do? What should we do? X hat. X hat. What should we do?
Inverse of ATA times
Okay. So finding, like this is just basic example problem. So you can compute ATA, and ATA will be 2 by 2. Or the size of ATA. Yeah, 2 by 2. Finding inverse of 2 by 2 is not that hard. So I may ask this. So find the result of ATA, which is 2 by 2. Find the inverse. You can do this. And multiply that by ATB. Okay. So that way you could do it, or you can just do. You can multiply A transpose both sides, then you get this here, and that is multiplied by X. The result of ATB is here. How do you find the solution? From chapter 1. Augmented matrix, yes. So if you don't like finding the inverse, you can also use augmented matrix. But if you prefer finding inverse, then you can just simply find the inverse and then multiply it, get the solution. Okay. this gigantic matrix, but it's good practice for you to do. So for this one, once you find x hat, I ask what is the error? What would you do? What is the error? Error of your estimate. Should I write? Okay. Should I write? X minus x hat? X minus x hat. Is it even valid? Because a few minutes ago, I said y minus y hat would be the error. But in this case, we're using x hat, right? Because what is meaning of x hat? What is meaning of x hat? What is the difference between x hat and x?
That's a true projection.
X is exact solution. But we cannot find x because B is outside of the column space of A. So I want to find the closest solution. I want to find the closest solution to the true solution. Okay. In that case, we just call that approximated solution at a least square solution. That is x hat. What do we want to? So what is x? What is the meaning of this x minus x hat? Error of what?
Where x is to where the projection is.
Okay. So let me. If I ask this, determine the least square error, the least square solution. So there are two errors. Y minus y hat, okay, or versus x minus x. Generally speaking, in mathematics, y is output, x is input. So do you see the difference? So we're using ax. We don't have y. So what is similar thing to what is corresponding term to y here? Is it ax or b? Ax is equal to b. So this is b. The b is what I want to what I am trying to approximate. I don't have the column space that is spanning that can span that can cover the B. This B. So I want to find the approximation that is that is y hat, and that is B minus A times x hat. Okay. So finding this error is totally different problem from finding this error. Okay? Okay? So usually you don't care about this. You don't care about this. This is what I care. Error between the object that I want to approximate and the approximation, my approximation. Okay? I don't care about this mathematics. Usually don't care about this. Now, go back to the problem. What is the error in this problem? How do we compute that? You find x hat, you find the x hat, okay? You find the x hat, you multiply, what was the a? A is 0.40211. You want to multiply a by x set, which is 1, 2. So you compute this and get the result and find the difference between between these two, b minus b, b minus ax, and find the length of this, and that will be the error. Okay? Does that make sense? Okay. Yeah, also try this for yourself. Oh, not now. We study hard. Try this too for yourself. Here, right here. So let's say I give you, I ask you to find the solution of this, and I also give you the 2R decomposition. So let's say I give you 2R decomposition. Okay. And then I want you to find the solution. Then you can simply find the solution from here. Right? X3. First we figure out X3 or X2, the next one. Okay? Or you can use the augmented matrix to find the solution. It seems like you're bored. Like tomorrow we'll use board. I don't like one direction lecture. But yeah, let me cover a little more. Yeah, I want to find the best fitting line for this data point. What do we do? Yeah, try this. And once you're done, then let's go. So exam 3, as I always did, I may not even change the numbers. So what I want to suggest is, don't just memorize the numbers and just don't write the answer. Okay? You have to show the word. Oh yes, 7.1 and 7. A little bit of half of 7.2.
Okay. Give me one question from each of those, or like?
Let's see. Maybe. Yeah, if I do that, and the difficulty level of each question will decrease significantly. Yeah, 7.2, yes, definitely. I gotta ask this. No matter what. Very important class. It's important. Is there anyone who is taking calculus 3 next semester? No? You guys mastered it? Good.
Are you teaching it?
I think so. Okay. How do you solve this? And same as last chapter, because instead of using a, we just use x. Now I want to find beta. I mean the coefficient of the betas, beta 0 and beta 1. Because we want to find a linear function that fits best for this data set. I have to find only beta 0 and beta 1. This is all I want. How do you find? Use this formula. So once you compute ATX, what is the size of ATX? 2 by 2? Is it 2 by 2? Really? 2 by 2? Yeah, 2 by 2. 4 by 2. Yes, you're right. 2 by 2. Therefore, finding the inverse of 2 by 2 is not that hard. So you can also find the inverse of this, or you can just use the augmented matrix like this to find beta 0, beta 1. Okay, there are two ways. Pick the way that you feel more comfortable. Doesn't matter for example. As long as you find the betas. Okay, I'll call it a day. See you tomorrow. Tomorrow is more day activities. I hate lecture by Oh, yes.